Hello, hi, Assalamualaikum, and a very good day to all students. So today we are going to do some revision on these two topics: series pipeline systems and parallel pipe system. Okay, the reason why I call it as revision is because most of the steps for these two systems have been learned in our previous lecture. Okay, so today, from the knowledge that we have learned, we are going to apply them in this two kind of system. Okay, first look at this series pipeline system. As you know, we have Q here. This is point 1, 2, and 3. Q1 is equals to Q2 and also equals to Q3. Okay, so another major thing in this kind of system is the losses. So the losses for this case is equals to major and minor losses in pipe 1, major and minor losses in pipe 2, and also plus major and minor losses in pipe 3. Okay. Okay, in my previous lecture, I told you that we have these three cases for this type of system. We have either type 1, type 2, or type 3. And all this, the example has been shown in our textbook. So please look at the example at page 68 to 75, and you can submit this after mid-semester break. I'm not going to do these examples with you because it's just a repetition from what we have done before. Okay, so now we can look at this parallel pipe system. Okay, in this parallel pipe system, Q1, the flows that is entering into this point 1. So this Q1 is equals to QA plus QB and plus QC. And this QA plus QB plus QC is equals to Q2. And this Q2 is equals to Q1. Yeah? Okay, so of course, there must be losses in these pipes. So the losses is losses in pipe A is equals to losses in pipe B and is equals to losses in pipe C. So it's different than the series pipeline system because here we add all the losses together. Yeah, but in this case, this is equals with A is equals with B and C. So we don't add them up. Yeah, but for the Q, yes, we add them, but not for the losses. Okay. Okay, so for this one, it's good if you can do the example because this is something slightly different from what we've done before. So let's look at this example problem 4 together. Okay, I will make it slightly bigger for this. Okay, this is exactly from the textbook, but I want us to look at this example together. Okay, so let's read. In figure 5.5, which is this figure, 100 gallon per minute of water at 60 degree Fahrenheit is flowing in a 2-inch diameter schedule 40 steel pipe at section 1. So this is the type of pipe. You will need this information to find losses. Okay. Okay. So the heat exchanger in branch A, so this is the heat exchanger, has a loss coefficient of K equals to 7.5 based on the velocity in the pipe. All three valves are wide open. Okay, so the three valves are wide open. Branch B. Okay, branch B. Branch B. So this is branch B. Oh, sorry. Okay, for branch B is a bypass line composed of 1/4 inch schedule 40 steel pipe. Okay, so you can see here that branch B has a smaller diameter than the branch A. Okay, Okay, the elbows are standard. Okay, the length of the pipe between point 1 and 2 in branch B is 6 meter. Okay, so the L is 6 meter. Because of the size of the heat exchanger, the length of pipe in branch A is very short and friction losses can be neglected. So for pipe A, there's no friction loss. Yeah, as it mentioned in the question. Friction loss is no. We don't have it. Okay, for this arrangement, okay, so let's see the question. Determine A, the volume flow rate of water in each branch. So we have two branch. So you would like to find Q A and Q B. Okay. Okay, so the second question is the pressure drop between point 1 and point 2. Okay. So we will do this together now. Okay, first, step 1. Step 1 is relate the two flow rates. Okay, so this is parallel pipe system. So you know that Q1 is equals to, this is QA plus QB, right? Okay. Okay, so we look at step 2. Step 2 is to determine the head loss. Okay, so when you have to determine the head loss, sorry, okay, so when you want to determine the head loss, so the head loss is from pipe A and pipe B, right? So head loss in two branches are equal. Considering the branch A as this equation, okay. So we are interested to know where this comes from. Okay, when we say this is the head loss in HA, so where this comes from. And then we also have losses from branch B. So the losses from branch B can be calculated using this equation. Okay, so we have to know where is this. Okay, that's all for this part. We will continue this video in the next session. Okay, next video.